the coordinates, it provides the distance, it provides the location. The third one, the third slide, the instrument which is called uh, a laser scanner, a 3D scanner. So we actually today we are working in the real world, and real world is a third dimension, having the third dimension. So as we see from our normal eye, it is not a two-dimensional paper map or paper drawing on which we are working. We are working on a three-dimensional drawings for the project. So it gives us a three-dimensional point cloud data, and when we have lots of point cloud data, then we require very sophisticated device and equipment actually to process the data. The okay, no, let me go back to the previous slide. Yeah. So that the next instrument is GPR. This is a ground penetrating radar. So those who are dealing with the microwave and the radar waves, they know that these waves have the capability to penetrate into the atmosphere and penetrate into the ground to a certain depth. So this instrument is actually emitting the radar waves into the ground. When we are moving this instrument over the surface, it is penetrating radar waves, and these radar waves are actually giving us the signals what is below the ground. So any buried object, water table, pipeline, or uh, electric line which is actually now passing through the ground, the underground utility, all the telephone line, electric lines, um, these are all actually now buried under the ground. And this is the one of the requirements of the modern city or the smart city. In many foreign country, you won't find now electric poles and telephone poles, because everything has gone underground. The maintenance is less, and also the wear and tear during the heavy winds storms is not there. So this particular device, which is called ground penetrating radar, is very useful to carry out the planning, utility planning, how to find out the best route for networking those utilities. The next image, what you see is the satellite image, high resolution satellite image. This is showing you the part of the Dubai, and this is why I am showing you actually this image of Dubai area, because this is one of the novelest example of civil engineering construction in the sea area. So this construction has actually taken place in the sea area, and there are very uh, posh buildings, uh, very costly residential area, and there's some commercial area is also there. So this is the shape of the palm tree, but this is the best example of a civil engineering construction in the sea area, because we find that the land area is limited, the population is outbursting, so we need alternate for that. So one could be we grow vertically, and another could be we use sea area for that purpose. The next bottom left image is there's an aircraft, and aircraft is fitting with some equipment here, and those equipment are laser based devices. So those who have electronics background, they know the property of the laser beam, and we are using this property of the uh, laser beam again to actually capture the coordinates of the ground features. So the aircraft flies, and several laser beams are sent simultaneously onto the ground, and this captures the ground information. The, the latest innovation is the last slide is about the drone technology. We call it the unmanned aerial vehicle. Technical term is unmanned aerial vehicle, UAV, but popularly this is known as a drone. So now, after the COVID pandemic, everybody knows what the drone is and how this can be used for the common facility also. So we are using this for collecting the data of the ground. So we have actually various disciplines, and major disciplines of this particular technology is land survey. So whether it is a mechanical engineering project, whether it is housing the industry in particular area, or whether it is aligning the telephone line or the electric line, or whether we have to find out the possible sites of microwave towers, we have to actually uh, work on the map, and that comes from the land surveying. When we do the survey part, when we prepare the map, and that is why you will find that all those service providers, we are using mobile phones of the different service providers, we are taking the services, and they have their own actually mapping systems, GIS based mapping system. Similarly, telecom industries, similarly the gas, pipeline supply, they are using the different kind of maps. So every industry today is requiring those up to date and accurate maps. So that will come through the land survey. So there are various techniques, supporting techniques, to prepare those updated and current maps. The second one is the photogrammetry, where aerial, uh, we are using the aircraft, and the property of the aerial photographs are used to collect the data of the ground and prepare those up-to-date maps. The third is remote sensing, where we have satellite images. You must have seen on Google Earth images. Those are very high resolution satellite images from the commercial satellites. So those kind of images today are very, very useful, because you can locate various facilities. You can find out which are the suitable area for your project. And these images are giving us the capability to do the planning right sitting in the office. So with the availability of the Google images on the Google Earth site, one can carry out so many other research activities also. So people are familiar nowadays what remote sensing satellite data is. Then global positioning system. Again, this GPS has brought a revolution everywhere. And we are using in our mobile phone, we are using in our wristwatch, we are using in our vehicle to tell us the direction of movement, or give us the navigation system. So this GPS is basically is very, very useful again to collect the data of the ground for preparing the updated maps. When you are collecting lot of information, then you need some kind of a software, so that the digital data can be analyzed very, very quickly. So if I have to find out, let us say, the alignment of a transmission line, so I can do with the help of the GIS. I can define my uh, criteria, my engineering criteria into the software, and according to that criteria, it will give me some possible alignment. I can change one of the parameter, give different weight, it will give me a different alignment. So I can find out that which is the best alignment for the transmission tower. Laser technology, this is the latest in the area, where we are using the laser beams, and these are collecting again the coordinates, X, Y, and Z coordinates of the ground features. Then last is the drone technology. So I will cover a little bit all of these very quickly, so that you understand the whole thing. But it is a multidisciplinary tool, as I told you, that it is now more the baby of civil engineers. People from different backgrounds, people from different specializations have become expert of geospatial technology. So lot of computer science, lot of architect, lot of electronics engineer, electrical engineer, they are using this particular technology in their routine work, in their applications, in the research areas. And just for your knowledge, we have a PhD program at IIT Roorkee in civil engineering department in remote sensing and GIS, where we are taking students from science background, physics, maths, chemistry. We are taking the students from electronics, electrical, architect, mining areas, computer science, IT field. Why? Because of this area has become totally multidisciplinary approach. And I'm happy. Actually, CIDC has organized the FDP program again for the mixed audience, the audience which has a mixed specialization. So this is fulfilling our requirement of the new education policy also, because in new education policy 2020, multidisciplinary uh, education has been given due importance. So there is no boundary between one subject and the another subject, one specialization and the another specialization. What we call as, this is the fudgy boundary nowadays. If I want to learn, let us say, today I want to learn mechanical engineering, there is no actually limitation for me. We have uh, the programs, the e-learning programs. We have the other media where uh, I can learn mechanical engineering and I can take a subject of mechanical engineering if I have interest. So this is a multidisciplinary tool where uh, uh, people from computer science, computer vision, mobile and game technology, IT field, they are all using this for different kind of application. So this is the electronic theodolite or electronic total station, which civil engineers are mostly using whenever some developmental activities are taking place on the Earth surface. This developmental activity could be industrial development of a industrial site. It could be alignment of a transmission line, or it could be construction activity, construction of a stadium or a multi-complex. So this particular instrument is very, very useful to collect the data. Then the next change or next improvement in this electronic total station is robotic total station. So we know that the robots are actually playing a big role in industry. So they are replacing the manpower, and particularly those dangerous areas. uh, uh, they are doing their work automatically where human being cannot go or cannot work. So the robots are also playing very, very important role in instrumentation outside the industry. Like this is a robotic total station and it is collecting the data about the land surface automatically. So when we say automatically here, the instrument is automatic in nature, but on the other side, we need a prism which is actually moved by the human being. So we require one person to carry out the whole operation, which was earlier done by several people in a group. Then we have the laser based instruments. So where you have to just throw the laser beam, like this is a bridge on the uh, top of the pillar of the bridge or the bottom of the pillar of the bridge, and it will actually give you what is the height of this particular uh, support, or what are the coordinates of these points. So from one particular location, you can send the laser beam to several points and you can cover a very, very large area. So its limit is 500 meter, which is a good limit. Half a kilometer you can actually take the data from one single position. When you are using actually the automatic kind of equipment, where you have to set the instrument and just instrument will work smartly and will collect the data, whole data. So this is a instrument which is kept actually on the monument, in front of the monument, and it is collecting three-dimensional data of the monument, Gateway of India. And these instruments got more popularity after the WTC attack in America, because those towers which were damaged by terrorists were not constructed exactly the same, because there was no three-dimensional data available. Only two-dimensional data was available. So then world over, there was a move that why not actually preserve the data of the important monuments and world heritage buildings in 3D mode. And these um, equipment, surveying equipment were very, very useful actually to fulfill the objective. So in India also, all the monuments and world heritage buildings now have been preserved in 3D mode. And you have to shift the this particular instrument on all the four sides and interior, and then you can reconstruct the whole model actually in your lab on your computer screen. So any repair work, any maintenance work can also be taken, because you can also find out that where are the minor cracks developing and which area needs repair. And also, this is the observation of Qutub Minar in Delhi. Again, there is a myth here that this is also inclining at a very slow rate, like Leaning Tower of Pisa. So you can also find out with long-term observation, you can find out whether really it is inclining to in one direction or not. And also you can take proper measure if it is inclining in one direction continuously. So this particular data, when this was collected to preserve the monument in 3D, lot of other uses came forward. Like tourism industry wanted this three-dimensional data. They wanted to create these souvenirs from a piece of wood or from piece of glass or piece of metal automatically. So these three-dimensional coordinates were fed into the machine, and from the block of a glass or a wood, the carving was done with the help of those machines. So the monuments or the gifts which were prepared, souvenirs which were prepared manually by the industry, now they are prepared using this three-dimensional data. Fabric industry came forward. Fabric industry wanted this three-dimensional data to print on the fabrics, print on the t-shirt, print on the saris, print on the other dresses, so that these monuments look, just like the real monument. So nowadays the printing industry is using this three-dimensional data. So next is the photogrammetry. As I told you, in the aerial, low-lying aircraft, the camera, a spatial camera is fitted, and that particular camera will look downward and collect the data about the land, so that accurate mapping of the land is available to us. So we have a very special camera. It's not the ordinary camera. Special cameras are available. Special aircrafts are available, which can fly to the area and take those photographs, and later on you can use these photographs for preparing the maps, for preparing the 3D models of the area. In our country, Survey of India, Dehradun, and NRSC, National Remote Sensing Center, Hyderabad, they are the government authorized agency which can fly for you, take the aerial images, and you can use those aerial images. The next is the remote sensing. You know that India is number 3 in space technology. We are much ahead from many, many developed countries. We are launching satellites, almost one satellite every year, and these satellites are providing us very, very useful data. So they are covering the whole globe. So that means that right sitting over here, if I want the data of America, if I want the data of Canada, some area I'll get the data. So I don't have to physically go to that particular land in order to prepare the updated map or collect the information or see what the ground is, how the ground looks like, what are the different features present on the ground. So that all is possible with the help of these satellite images. And today we have very, very high resolution satellite images available, where you can even see the vehicle which is parked in your in front of your house. So you can even locate the vehicle. You can even find out what model of the car is, with the help of the dimension and with the help of the shape. So these images are very, very useful. For example, when we carry out flood mapping, water pollution mapping, deforestation activity, snow cover, urban sprawl, or crop yield estimation, or in case of a disaster is taking place, the disaster management. So in various areas, these images are being used by various experts. Then GPS, you must be having in your mobile GPS chip. That chip is actually giving you the crude data, crude coordinates. But if you want much accurate data, then this device, the GPS instrument, you have to procure. This is slightly expensive, but there are different instruments which are available, from handheld to the instruments which you can mount on the camera, mount on the tripod, and take the data. So this everybody is familiar with the GPS because we have lots of application in our normal day-to life, like location survey, like the delivery person will deliver the goods to your doorstep uh, with the help of the GPS, the location, and with the help of the high resolution satellite images. So if you have to order something to Zomato, you can get the supply at your doorstep with the help of the maps, high resolution maps, which are available from the satellite image, and the location which is available from the GPS. The GIS is basically a software which can do a lot of things for you, which can be used for storing, editing, interpreting, analyzing, visualizing, querying, sharing the data, integrating the data. So all that information, multiple information which you are collecting from the multiple sources, and you want to integrate them together, and you want to derive a useful result, or you want certain query from the data, that is also possible with the help of this device. So all that digital data which you are having, which you are collecting from different means, you can analyze it very quickly. You can produce new information, and you can produce new maps with the help of that. So when we see the application of geospatial technology, in fact, this is only a very small list. Actually, there are very large number of geospatial technology application. There could be many slides if I wanted to show you, but this is just the exemplary list. Whether we are talking of today climatic change, whether we are talking of the meteorology or agriculture or mineral and oil exploration, infrastructure development or telecommunication, or atmospheric modeling, or business, or crime mapping, this geospatial technology has very important role to play and can provide very useful data in several government projects. In fact, it has become now almost mandatory to use the geospatial technology in large projects, big projects. So whether we are talking of today, digital India. So digital India, we are using the GIS very, uh, you can say, extensively. So this the first balloon which shows is the digital India, and the GIS is providing us a decision support system. So it can be developed as an expert system or a decision support system. You must have heard about the smart cities and Amrut cities, because the India will have 100 smart cities, where everybody, including the mechanical engineer, electrical, electronics engineer, IT specialist, computer scientists, architects and planners, they are all playing very important role in the smart city concept. And here GIS and satellite images are also giving us a lot of inputs for the planning. Whether we are talking of the National Mission for the Clean Ganga, Afforestation Program, or Northeast Regional Urban Development Program. So we take any government project nowadays. These geospatial technology are providing a lot of data to us uh, in planning and execution, and even after monitoring, afterwards, post construction monitoring. This slide shows a little older, 2016 data, but it is giving us some kind of a pattern. What are the areas, which are the areas where this is being used, the infrastructure or land administration or urban development or electricity, telecom industry, oil and gas exploration, the mining areas, disaster management, defense and security. So you can see here that the dark blue color is the area which shows the present use, and the lighter blue area shows the future use. So maximum use is done in the infrastructure planning, and then the agriculture, and then there is a application in other field also. So GPS basically is providing us a very good amount of data with uh, least efforts. This instrument, in fact, we have to carry in the field wherever we want to collect the data. This instrument we have to carry, and this is a global positioning system. That means this works globally. Anywhere we take this instrument on the globe, and it will give me the position. Position is in terms of the latitude, longitude, and the height. Because the civil engineers say latitude, longitude, and the height with respect to mean sea level or with respect to some datum. But in general, the people say X, Y, and Z coordinates. So it provides us X, Y, and Z coordinates uh, whenever we use this instrument in the field for any of the object. So I want coordinates of, for example, the electric pole. So I will just stand near the electric pole and get the coordinates of that particular location. So this handheld GPS is also very, very useful in many applications when my area is very large. When I am covering a large area, suppose a road is to be planned and length is 60 kilometers, then I can use. I don't require very precise instrument which will give me millimeter accuracy or centimeter accuracy. So I can use an instrument which can give me only some meter accuracy, like handheld device, GPS device is good enough. So this is roughly the size of your mobile phone, slightly bigger. You can keep in your pocket, and you can use it to collect the three-dimensional data of the ground to get the location. People are using a combination of electronic total station and the GPS when it comes to the 3D modeling. So as you can see, the second image is the ground. The person is standing on the ground collecting the information about this particular bridge. There is electric pole and there is a road here, and the bottom colored image is the point cloud data, and you can see here that electric pole has come out very nicely. You can see the road, you can see the bridge from the data. So three-dimensional data when you are collecting, so sometimes you have obstruction in front of the object. So in order to avoid that, you can use the GPS because you are catching the signal from the satellite. So whether it is a construction industry, in construction industry, we have to actually, uh, some of the machineries are to be installed, on a firm ground, or at a certain height. So all that in the industrial area, all that data can be provided with the help of the GPS. If you want to monitor the health of the bridge, because in our country many of the bridges were built during the British time, very old bridges. So there is a lot of reflection in the bridge when there is a heavy load, when there is a train moving, or when there are two trains moving in the opposite directions there. Then you will find that there is a deflection in the bridge because they are old bridge. So one can find out whether the deflection is permissible, or this particular bridge needs replacement, or repair is required. This is the field data collection with the help of this GPS instrumentation. So what you see, the circular one is the plate which receives the signal from the satellites. So it is basically, all communication problem. So it is receiving the signals from the satellites, the GPS satellites, which are 24 satellites moving in the different orbits, and This is the controller in the hand of the observer. So controller will actually display all the observation and you can control your entire survey work, store the data over here. But what is recent here at the backpack, you can see the backpack, which is a radio beacon system, again a communication system. So at the backpack of this person is you can see the spike coming out of it. So it's a radio beacon system, and this beacon system is communicating with the headquarters. So you can communicate directly, transmit your data to a central server. So if there are 10 different persons working in 10 different areas, they can transmit their data in real time to a central place, and the person sitting at the central place can do the analysis. So this is called, kind of a real time uh, data collection and real time analysis of the data. So whenever some accident take place, these kind of studies are being done nowadays in many foreign countries. The real-time analysis of the scenario is done with the help of the data transmission. So this is showing you the Earth surface in the center and the different satellites at different configurations which are moving around the globe. So because they are in large number and moving in different orbits, so anywhere on the globe you go, you will receive the signals from some of these satellites. So that is why these satellites are visible. Minimum 3 satellites are to be visible. If there are more than 3, it is much better. So you get good intersection of the point and can get the coordinates of it. The technology has changed, and so is shown here that if you want to collect the GPS data for a large area, if you want to do the GPS work for a very large area, so it is not possible physically actually to carry this instrument from one place to another. So you can mount this instrument on a simple vehicle. It's a normal car. It is not something special here. So in the normal car, you have the receiver on the top, which you can mount, and then you can see the controller, is in the mount in the window, near the window. So the controller and receiver, they are set in the automatic mode, and you simply move the vehicle, and the GPS will start collecting the data. So biggest advantage of such kind of a technology is that wherever you want to, wherever you can take your car, it will automatically collect the data. You are not actually focusing on the instrument. So this is called the what we call it, the smart instruments or intelligent instruments. So this is uh, the high resolution satellite image in the background, and the green and the blue line are those lines where you have moved the vehicle with the GPS. So why there are two colors? The red colors are indicating the vehicle has stopped there, maybe due to traffic jam, or maybe the traffic signal light, and it was collecting repetitive data at these places. So this is giving me an indication, for example, that probably these are some bottleneck areas. These are the areas which require some improvement in the road condition, widening of the road, or making some road one way or the other road, these kind of things, so that there is no traffic jam on this. The next instrumentation is the ground penetrating radar instrument. So it emits the radar beams, and this is like a trolley. You must have seen the trolley on the airport. So similar to that, you are keeping the instrument face down. So this is the actual instrument which you see in the second slide, face down. So this instrument is kept in the trolley here, face down, and there is a controller which is mounted on the handle. When you are moving this particular trolley, you can see on the display devices. So this is a very useful instrument, and this is called non-destructive technology. Earlier it was trial and error kind of a procedure. If there's a pipeline going, if there's an electric line going, so one was doing only trial, digging the road by the side of the road at different places, and then ultimately found the location. But today you can pinpoint the exact locations of those underground utilities with the help of these devices. So that is why this is called non-destructive technology, NSD. Non-destructive method is there. You can actually pinpoint the problem area. So this trolley is moved over the ground, and the radar beam will penetrate to the ground to a certain depth, and it will give me information whether there is a pipeline below the ground, or whether there is a copper wire found, or something like that, or there is a buried structure. So, for example, this particular slide is showing you the person is moving that particular trolley, and there is a drainage pipe below the ground. Then there are different kind of a soil layers are there. So this is one layer, dotted line. This is another layer. So from every point, there will be a radar beam which will strike to that particular object and reflect back. So it will receive those reflected radar beams, and those signal, the transmitted signal and the received signals, they will have a different characteristics, and one has to understand these characteristics in order to determine what kind of object could be possible below the ground. So this is the kind of a profile one get. Actually, I'm showing you this because this is uh, was a project which was carried out in Delhi, and there was a sinkhole actually in the road, and every time the PWD engineers repair that road, after few days, the that particular portion will again sink into the ground. So when GPR observations were taken, it was found that there's a pipeline going actually in this area, and there's a leakage of the pipeline. And because of the water, because of the leakage, that sinkhole is created. So when the pipeline was repaired, that problem was gone. So there are multiple applications. Again, if we see the application areas, whether we are working in the tunnel or road beds or the railway embankments, bridge decks, river buildings, monuments, cables, pipelines, buried structure. So a lot of applications are there for this particular technology. And foreign country, actually it has become mandatory to keep a record of the utility underground mapping also. So in India also this is catching up. Then we have another technology which is called the LiDAR technology, which is the light detection and ranging. So LiDAR, with the use of the LiDAR technology, LiDAR based instrumentation, we can get very accurate information of the ground. So one can collect very high resolution data in a shortest possible time. So you can save a lot of time, and you can get very, very high accuracy with the help of the LiDAR technology. So this instrument which you see here, it is basically a 3D laser scanner. So this is called terrestrial because it is kept closer to the ground. So you can see a bridge, a steel bridge, and there's a railway line passing through that bridge, and when the train moves on this bridge, there is a deflection. So this particular instrument will give you how much is the deflection at the center point, how much is the deflection at the other points, and one can find out whether that is within the safe limit, or whether this particular bridge has to be repaired or replaced. So this when this will scan the whole area. So we have, we must have heard about the paper. We have seen paper scanner. We scan our paper, but this is scanning the ground, scanning the features which are present on the ground, so that more accurate land data could be produced. So this is giving us a three-dimensional data, because we can see the Earth surface as three. So different kind of 3D laser scanners are available nowadays. They are little expensive at present, but as the technology is adopted, technology grew, the prices will go down. So you can see here that this 3D laser scanner is being used by the person in the second slide, and there is a structure which is the uh, bridge overhead bridge, and there's a road, So it is collecting the data. So the third slide below is the data, point cloud data, which has been collected by this 3D laser scanner for the whole of the ground, and 3D model has been created. So one can find out, in fact, deformation or deformation in the tower or cracks in the buildings. So there are actually, like for example, we have carried out the projects for transmission tower, which are very high towers. And when the transmission tower was constructed, at the end we find that this is not truly vertical. Those transmission towers are not vertical. So Doordarshan or other agencies have contacted us to find out how much is the inclination, in which direction it is, inclination and deformation, uh, because the tower has to be vertical. So the that also, you can find out very easily with the help of this instrument. So you can create a very high resolution 3D model of the object which is in front of you. And suppose your area is large again. So this is a mobile mapping system, what we call as MMS. If the area is large, again, you have the technology available today where you have the entire mobile lab. So this is the kind of a mobile lab, uh, a normal vehicle, but on the top of it, you have a provision so that you can, in place of the luggage carrier, you have the carrier here which can mount your instruments, which can mount the LiDAR based instruments, which can mount the camera or GPS devices, so that you move the vehicle and collect all that data while you are moving. So you are not physically shifting the instrument from one place to another place in order to collect the data, but using the mobile uh, vehicle, you are collecting the whole data. So you can see on the top rooftop, this is uh, IMU, this is the GPS antenna, then we have the digital camera, then we have the laser scanners are there. So one can see there are a lot of instruments which are fitted over there, and the whole idea of these instruments is to give you picture as well as the coordinates, location, because the location has become very important. But when we are talking about the images and the pictures, you know, there is a latest innovation in the camera technology. And that latest innovation is, as you can see here, it is the 360-degree camera. If you see the right slide, the word 360-degree digital camera is written. And these 360-degree digital cameras are available not only for the technical work, but they are available for the normal photography also. I can buy a 360-degree digital camera now and carry out the landscape photography from one vantage point all around me. So at present, what we do from our normal camera, we point out in one direction and take the image in that direction. So if I have to take your image, I'll point out my camera towards you and take the image. But if I have to take the images the back of me or on the left side, on the right side of me, again I have to move my camera in that direction. But with the help of the 360-degree camera, from one single point, I can take the images all around me. So multiple images would be there, and I can create panoramic view from one single point. So it saves lot of time in data collection. When you are out in the field, you can save lot of time there. So these 360-degree cameras uh, are nowadays available in the market. So when you are moving that vehicle and collecting the data, so I'm showing you the sample of the data. The top image is showing you a railway track. This is a railway track, and by the side of the railway track, you can see the pinkish kind of a color. These are the trees, and then there's a platform. So you can actually see even the cracks in the railway line. So for the maintenance of the railway track, these kind of images are very useful. And the bottom image is a image for the hilly road. So you can see lots of curves in the road. So this is the hilly area, and one can find out from this uh, hilly roads, which are the areas, uh, which are the spots, which we call as the black spots, or where the accident prone areas, and their additional uh, additional precautions are to be taken, or road is to be widened. So one can actually visualize the entire data from one uh, simple move. So this mobile mapping system is very useful uh, in collecting the data for the smart city, or collecting the data for the urban setup. If we have to find out the urban growth in a particular area, what are the different features and what are their exact dimensions. So one can get actually all that moving in the vehicle. So the biggest advantage of this is that you can move in the crowd. So you are not waiting for crowd to disappear. You can move your vehicle in the crowd and still collect the data. Earlier, you were working with these instruments when there is no crowd, when there is no obstruction between the instrument and the uh, line of sight which you are collecting the data. But today you can collect the data for road and rail survey, dam site, tunneling, monitoring of the area. So you can see the building here, this particular building on the left. This data has been collected with the help of the 3D laser scanner. So in many infrastructure projects, it is being used. This is a automated road survey system as an example, extension of the equipment which we are showing you, mobile mapping system. So this is a automated road survey system, very useful system is there, because it concerns everybody. When we travel on the road, we see lots of potholes are there, particularly after the rainy season. Lots of cracks are there. So it will not only give wear and tear to our vehicle, but it will increase our travel time also. The speed of the vehicle would be slow, and there will be a lot of wear and tear in the vehicle. So it concerns everybody how we can have better roads for transport. So this automated road survey system basically is collecting the data from different technology. So it has the GPS, it has in the front the laser monitoring systems, it has the camera on the top. So, and these all the data is collected just by moving the vehicle on the road and then processing this data. So there is a data processing, data acquisition system fitted in the vehicle itself. So there's a small computer to process the data right on the road. So real-time data collection and real-time data processing is there. So you can see immediately the results of that. So this is this automated road survey system. There are few available. So one is available in Central Road Research Institute, New Delhi. So I'm showing you that instrument, that vehicle which is available at Central Road Research Institute, New Delhi. And here is the laser profiler. So it will scan the profile of the entire road. Then we have the camera system, we have the GPS system. So it will, then we have the camera system. So two cameras are there. And when we are using the two cameras, we can create actually a 3D model. So stereo mode. So it is collecting the data in the stereo mode. You can see one camera on the top here, another camera here. So you will get the two images of the pavement surface, and you can create a 3D model. So the advantage of 3D model is that if you have a big potholes and several potholes in the road, you can calculate how much volume of the material would be required to repair the road. So there is no need actually to have the repair of the entire road, but only patches can be repaired, money can be saved, and the volume computations can be done with the help of these devices. So they are helping us in maintaining the road infrastructure. Then aerial LiDAR survey, where you have the LiDAR based instrumentation mounted on the aircraft. So they are low-lying aircraft, and this was actually started in 1960, but that time it did not get so popularity. But nowadays, this LiDAR-based technology is gaining popularity, particularly if your area is large, if you are working in a larger area and you have to do some planning in that area, some development, some infrastructure planning has to be done. So you want quick data collection. So you want to save your lot of time. You don't want to spend too much time in the field. So mount the camera, the LiDAR-based instrumentation in the aircraft and collect the data for the whole area. So when you are collecting the LiDAR data, you are collecting three-dimensional data. So what you see, you can see the height of the buildings and height of the structures which are present on the ground. So one can see, if you want to construct something here, so you can see that how high you can go with that structure and how the object would look like with respect to the surroundings area. So this LiDAR technology is getting popularity in collecting the two-dimensional data. I'm showing you a two-dimensional data here, plan of a certain area, Seoul, South Korea area. So this is a point cloud data on the left. Different uh, colors are basically indicating the different kind of features over here. This is the black and white on the right side. So you can see this is the railway track, and one can see all the road network, individual buildings. So one can actually collect lots of information very quickly. But if you want to do a 3D kind of a study, so this is a 3D data. Green area is all the forested area. The white area is all that sandy area, riverine areas are there. So if you want to see individual feature and height of the feature, so this is LiDAR data for a small area, and I will blow it up. So if I blow it up, now you can start filling the individual tree, and you can see those small channel and white area. So one can have a feeling. So the now further blow up it, you can see individual tree. So you can actually, similar to that, you can find out height of any object, location of any object with the help of the LiDAR data. Then you can create a kind of a elevation model. So this is called, we call it a digital elevation model because it's a three-dimensional representation of the ground in the computer, and this is called visualization of the terrain. This has become very important research area nowadays, how to visualize the ground as we see with our normal eye. Can we see it on the computer screen with the help of the software right sitting in my office? So this is possible nowadays with the help of the 3D modeling techniques, and this 3D elevation model is showing me the topography of the area, that which point of the ground is higher. This is the higher ground and this is the lower valley area. So one can actually carry out some kind of a planning related to that. So, like civil engineer might be interested in finding out the suitable site for the dam structure. So, where we have to find out the dam structure, or in the satellite image, one can see the location of the powerhouse, how the powerhouse will look like, the sluiceway, the spillway, the structures, and all that. So one can use those high resolution satellite images and can find out which are the suitable areas, in fact, to do that. When we are using several multiple images for multiple dates, like this is 2015 December image, left one, and the right one is 2040 2018 image. So three-year difference is there, and we can visualize uh, manually also that some of the water bodies are shrinking, particularly the top one. So you can see very large water body, but you can see the shrinkage of the water body there. So one can analyze the change. One can find out what are the suitable sites for the dam, can use some kind of a criteria. So the same engineering criteria, the same geological criteria, topographical criteria, which were using manually, now we can use GIS capabilities and carry out that kind of a analysis. So here, for example, they are the different kind of themes here are there: slope of the ground, the land use and land cover, the geology features, the proximity to the river, and then what are the different soil types, what are the catchment area, and on the basis of that, one can prepare suitability kind of a map. Like this blue area is highly suitable area for the dam. Similarly, one can find out the which are the suitable sites for erecting the transmission tower in the area. So one can further carry out some kind of a quantitative analysis from that data. You can also, behind the dam there is a reservoir, so you can find out how much will be the volume of the water stored in the reservoir at any particular day. Now I'll talk a little bit about the satellite images. So you know that India has been in the forefront of launching the satellite right from the 1979 when the Bhaskara was launched, and then in 1982 full-fledged systems, the IRS, Indian Remote Sensing satellites, and then lots of satellites have been launched, are being launched. Some are like INSAT, some are telecommunication satellites, uh, and some are remote sensing satellites which are providing us very high resolution data. So all these gamuts of satellites are providing us very high resolution, up to 1 meter resolution to 1 kilometer. So if I am working in a larger area, let us say the whole India, then I have to go for 1 kilometer resolution. But if I am working in a smaller area, then I have to go for 1 meter kind of a resolution. So today we have several images available from worldwide satellites. So whether it is an American satellite or is a Canadian satellite or it is a Iconos or QuickBird, which are the commercial venture of the satellites. So we have Indian satellites, French satellites, uh, and then Canadian satellite, American satellite, Chinese satellite. So we have lots of satellite data available to us, and at different resolution. So depending upon my requirement, I can go for a proper resolution and carry out the analysis from that data. Like it is administration also is using this high resolution satellite data. Like in Allahabad, when Mahakumbh took place first time in 2001, this high resolution satellite data was used. This is the Sangam area in Allahabad, by administration to plan, where would be the camping sites, what would be the parking area, where we'll have to uh, construct the temporary bridge, where will be the movement of the vehicle and how the Shahi Snan will move. So all that planning was done on a high resolution image. Then later on, whenever such kind of activities took place, religious activities are taking place, the administration is taking help of such high resolution satellite images to carry out the planning and management of the crowd. So this is the radar images, if one has to see the geology of the area. So let me skip those slides. Everybody knows the tsunami in 2004 created a havoc in the area. So this is the remote sensing image of 21st December 2004, and you can see the island it has a lot of lush green vegetation, and that is why this pink color is appearing on that. And once the tsunami took place, this is 26th of December 2004, one can see that a lot of water has entered into the land area, into the island area, and a lot of muddy water is there, and the water which was so clear and giving us, the dark blue color, now it has become all muddy water. So one can actually, comparing the two, one can carry out the damage kind of assessment and find out which are the safer areas. So these images have been found very useful. to government, to administrator, whenever some disaster activities are taking place. So this is, for example, a satellite image which shows that there is a road here in the center and there's a small river which is passing close by to the road. And as per the habits, the people are settling down along the roads. Then you can see to 1986, the urban area is growing. In 1992, when there's a flood in the river, it will definitely harm those urban areas which are closer to the floodplain of the river. So it will definitely harm those people. So you can carry out, this kind of a change analysis from those satellite images. So one can assess how much land is damaged, what kind of uh, land was there, whether it was agricultural land or it was the urban area which has been damaged by the flood. So the urban growth of any city has become so important whenever we are talking of the sustainability, which is the goal, sustainable. We have to attain the sustainability, and the United Nations is working very hard with the help of all the countries to achieve the sustainability by 2030. So, in order to do that, we have to, very alarming factor is the urban growth. So, how the urban area is growing, and it is growing everywhere, not only in our country but in other countries too. So, we have to actually see whether the growth is in the right direction toward the sustainability or not. So, that one can assess with the help of the satellite images. Then building identification. You can identify the building, the infrastructure from the satellite images automatically. Visually you are seeing the building, but automatically you can develop the kind of a algorithm. So here, where you need the help of computer engineers to develop such kind of a logic algorithm into the image processing software so that they pick only the building. So this is the automatic building detection by the algorithm. So every building will be detected and you can find out the area of the building, and this is very, very important. In fact, to the local uh, administration like municipality would be interested to know how much is the constructed area in a particular ward, in a particular locality, and they might be interested to know whether there's any illegal building which is coming up. The identification of the slum building has also been done with the help of the satellite images. This has become quite important when COVID pandemic spread in Mumbai area, and particularly in the slum area. So slum mapping was very, very important because administration wanted to know how much is the area under the slum category so that that can be quarantined. uh, Railway line alignment, people have used aligning the new railway line or high speed railway tracks which are coming up, or widening of the existing tracks, these satellite images. So this is the alignment kind of a uh, process. Civil engineers know that they are using certain criteria in order to do that alignment, but similar kind of alignment can be done uh, for the transmission line or the power line, defining the criteria. So this is a railway line alignment which has been done, and actually, one can along the railway line, one can find out where the tunnel is required and where you have to have railway stations, all that. This image is for Ramganga Reservoir, which is in Uttarakhand, and there's a Ramganga Dam in Uttarakhand. So you can see a big reservoir, a water body. The dark blue color is showing that. The white color is indicating the snow cover area in the top reaches. So this reservoir, uh, they are the lifeline and they are providing us the water for different activities. So you can see that how to sustain, how to make the reservoir which can sustain for a longer time so that there is no sediment deposit in the reservoir. One can do this kind of a monitoring with the help of the satellite image. So these are different date satellite image, and when you like to actually use the algorithm or some kind of a methodology to identify how much is the sediment coming to these this reservoir at different times. So using that algorithm, one can only pick the reservoir area, because we are not interested in other features. So in different months and years, the shape of the reservoir, the area of the reservoir, one can analyze with the help of the digital image processing techniques, and can do that kind of a computation. So one can find out, if you know the height of the water level, you can find out the capacity of the reservoir using the remote sensing satellite image. This is, Kosi River, which every one of us know that this is the river which floods every year, which creates a lot of havoc in the area and loss to the uh, life of the people and the land, because this Kosi River is continuously shifting. So it was flowing earlier somewhere this side, the right side, and then it is continuously shifting toward the left side. So this shifting of the river, one can also identify with the help of the satellite images taking with the different years, and then digital image processing techniques you can use to identify the water pixels from that, and can use some kind of a threshold here to pick the water pixel, and then you can also find out braiding of this particular river and the scenicity of the data. So I'm showing you the results. So this is the algorithm which picked up only the water pixels. So one can actually, this particular area is enlarged and it is shown in the circle over here. So you can pick up the uh, pixels which carry the water, and you can get the shape of the river, how the river is flowing during the uh, pre-flood and the post-flood area, and then you can find out how much area is under flood. So that kind of a study can be carried out, and shift in the river with respect to time can also be calculated. So this kind of study are very, very useful whenever we have to protect some area from the flood damage. We have to design some kind of a structure on the river to change the behavior of the river so that the area is not affected. Then lastly, I'm showing you the drone technology, which is upcoming area, very, very popular, and a lot of people are aware after the COVID pandemic, because the drone was used for disinfection of the area. It was used for supply of the medicine. It was used for supply of the goods for the houses in world over, and it was also used to warn the people, those who were moving out on the street or on the road, even during the lockdown period. So this particular technology has lots of application. Again, the list is not complete here, whether it is the transmission line monitoring, or it is oil and natural gas mapping, or it is the law enforcement, or delivery of the medicines or the goods. So we are using it in different fields, and this is the LiDAR data, because this particular UAV can actually carry LiDAR instrument. It can also carry the photographic camera, take the images. So this is the LiDAR data, and you can see the power line. So this is a tower here, this is another tower, and this is the high tension line which is passing through the area. So one can even see those alignment and wires. One can count how many wires are there, and also you can see each and every feature. If I blow it up, you can see each and every feature present on the ground, and can also determine the coordinates, the height of a particular feature. So civil engineers do a lot of topographical mapping of the area. It is very, very useful for that topographical mapping, and can find out the elevation contours from there. Then From the elevation data and X and Y, one can do the volume computation. In traffic monitoring and management in foreign country, this is being used very, very frequently in monitoring the traffic rules and regulations. If somebody is not violating it and somebody is not rushing with a higher speed, so that is done with the help of the drone technology nowadays. So this is being done, and in road transport, whether we are talking of the speed control or whether we are talking of the traffic count passing through a particular point, or maintaining a sufficient distance between the two vehicles. So we are using uh, drones which are low flying drones and drones which are slightly higher flying drones, and they are providing the data. As you can see on the top is a control station, so they are providing the data at the control station. So this is the low flying drone which is actually monitoring the movement of the vehicle on the highway. Then, uh, identification of the building with the help of the UAV images, people have done that. So this is a 3D model which has been created with the help of the UAV image, drone images, and you can see the damaged buildings. The front portion is damaged, and one can also do the estimation how much cost would be required in order to renovate that particular building in that particular structure. So this is another example of the 3D modeling of the area by taking the images from the drone. Drone is very, very useful in smart city applications. So whether we are talking of our infrastructure inspection, it could be inspection of industry, inspection of the pipeline in an industry, inspection of the bridge, where it is difficult for the human being to go. This drone can actually, uh, we can send the drone there in those areas, and it can take the images or collect the LiDAR data. Then delivery purpose. So the delivery of medicine, delivery of goods, delivery of books, and the other day I was seeing a program where even the morning tea is being delivered by the drone. So in the morning tea is delivered, bed tea is delivered by the drones in the balcony of the the residence. Then taxi UAVs. This is coming. This area is growing in a very, very big way, and there are tests which have already been conducted in Singapore and in other countries, and they are successful. These drones are successful in carrying 5 to 6 people up in the air. So they will fly at the low altitude, and they can be used as a taxi also. So this will come up in India very, very soon now, uh, because the roads are so congested, and sometimes you have to travel from one place to another place in the shortest possible time. Whenever there is an emergency, or if you have to catch a flight and you are stranded in a traffic jam, then your heartbeats go up. So these taxi UAVs will fly uh, at a certain height up in the air and will take you very fast from one place to another place. Then traffic monitoring could be UAV, and environmental monitoring by the UAV. For example, you must have heard that after the Deepavali, uh, there was a lot of pollution in Delhi area, in NCR region, in Delhi area particularly, and the Delhi government has took many steps, including the closure of the schools of the children, and this monitoring of the environment, because you can fit in the sensors which can actually sense the environment, and they can actually monitor the environmental conditions and give some sorts of warning to the people so that the further damage is not done. This example shows the how the construction industry is benefited. So you can see a building here, the construction is going on, you can see the scaffoldings are there, the construction is going on, but at the same time you can see the drones at different altitudes. So if you see the number 1, 2, 3, 4, 5, 6, and there are drones which are flying at a low altitude, and the drone which is flying at a slightly higher altitude, the drone which is looking at a particular angle and taking the images continuously to the area. So the area could be the survey of the land, inspection of the building, providing visual material for the clients and the staffs, monitoring on-site activities, security surveillance, because this has become really a big challenge for the people, that how to secure the particular area and mapping the data. So these are done with the help of regularly now with the help of the drone technology. And in construction industry, the everyday's progress can be monitored with the help of these drones. And like uh, many state, the PWD engineers and all that, they are what, particularly Arunachal Pradesh, I was reading that because the state has lots of hilly areas, and it is very, very time consuming for engineers to go to the site every day. Say, so they, what they do is they are monitoring their construction sites with the help of the drone images, right, sitting in their office. So this is the caricature which shows a construction site of the future. So we have, many activities while construction is taking place. Large constructions are taking place. So all those construction activities will be actually with the help of the IoT, Internet of Things, with the help of the connected sensors and the geospatial technology, drone technology can be monitored and can be managed very, very well. Then unauthorized construction is another area which is a big headache to the administrators. So all those high resolution images which are taken by the drone camera, one can monitor the unauthorized construction, because if you take those images at regular interval, industrial applications, suppose there's a long pipeline actually going from one place to another, maybe it is a gas pipeline, maybe it is a oil pipeline, so leakage or maintenance purpose, the drones are very, very successful, because it is not possible for human being to keep an eye every day. This is a cost comparison, when you are using drone technology and when you are using the traditional land surveying technology, it is a linear curve. But the curve goes, stepped kind of a horizontal, then there's one step up and then one step up and horizontal. So as the area, you can see the area is on the x-axis and the cost is on y-axis. So the drone technology is saving a lot of time actually to carry out the work. So dam site inspection, a lot of dams in our country are developing the cracks and they fail. So to stop or to take the proper measure to stop them with the failure, these technology are collecting the data of the different dam sites and providing us the information whether the crack is developed or not, or the dam site is safe or not. So this is a dam site, Maryland in US, where the 558 images are stitched together with the help of the software, and you can see the entire view. You can see the reservoir of the dam and other structure. So these are the point cloud data. You have the LiDAR laser beam data, and these are the point cloud data. Upstream, downstream of the dam, top image, and bottom image, the upstream of the dam. So you can have this. Then GIS is playing very important role, because the entire thing has to be integrated. All the data which you are collecting from any of the source, you have to integrate. And today we are using that term which is called the big data. When you have a huge data, it becomes the big data. Handling the big data, you require a different approach, a different algorithm. You require, the cloud services also in that. So this is the GIS which will actually integrate all that information so that you can apply that information into it. So if we are talking of the construction industry, again, you can see that there are a lot of applications are there where you can apply the GIS, whether it is the site location, whether it is the construction scheduling or progress of the data and so on. So for a lot of activities, whether in the form of the numerical value, in the form of the graphical value, in the form of the bar chart, one can monitor. So these are the different steps. So, one can use mm, uh, in the GIS. When you have the AutoCAD file, import the AutoCAD file, and then progress can be monitored of the area. So I'm not going into I'm skipping all that information to you, that how this GIS is being used in AutoCAD, right? Uh, 3D campus modeling. Several universities and several institutions on their website, they have shown their campus in 3D mode, how their campus looks like. And this is very, very common in foreign country. When the students uh, want to take the admission in a particular institute, they would like to see the institute also. They would like to see how the lab looks like, what are the different equipment, how their campus is. So all that 3D model of the entire campus is built using those geospatial technology. So in India, we have the orientation program. We call the student to the campus. Group of students are physically shown, but this is not common in foreign country. They have a entire 3D model, a walkthrough model is there, and using that 3D walkthrough model, one can see their entire campus and take the decision that whether this campus is good enough for them, or to take the admission, or they have to go to the different other campus also. So though all that 3D modeling has been done. So people have done, for example, this is one example of earthquake simulation. We know when the earthquake take place, there are a lot of damage to the area, to infrastructure, to our communication systems. So everything is disrupted. So this is a kind of a study one can do with the help of the satellite image, find out the what is the land use here, what are the household size, how many floors are there, how many, what are the building construction types is there. Then if the earthquake at Richter 7 scale take place, which are the buildings which will be damaged. So like you can do the simulation kind of a study, and using that simulation kind of a study, I'm showing you a quick result of uh, this is a road, and on the both sides of the roads you can see the houses. So this shows basically when the earthquake take place in this particular area, those brown colors are those areas which where the building will be completely damaged. So you can see from this particular diagram that red are those buildings will be totally collapsed. Pink will be the major structure failure. But of course, this is all a simulation study on the basis of the data collected. That these are the speculation that if the earthquake take place, so many buildings will be completely damaged, so many buildings will be partially damaged, so many buildings will not be damaged at all. So road blocks, which are the road which will be blocked? Like for example, you can see that this particular road will be completely blocked. So there will be no movement on this road, there will be no movement on this particular road in case the earthquake takes place. One can actually monitor the activities, construction activities also on various day with the help of this. So this is the progress of the structure. One can monitor the progress with the help of this 3D simulation model. Uh, how the building or the infrastructure is progressing on different days. So that is also visualization, is also very, very important area nowadays, and geospatial technology is playing very, very important role in this visualization. This is showing you the visualization of the flood. So in case there's a flood in the river, how much area is likely to be damaged, and which is the area where first affect the flood area. So this is the spatial and temporal uh, pattern of the overflow, and you can see that the water which is flowing into the channels in case of the rainfall there, all that water will be collected. So one will know that if there is a rainfall in the upper areas, in the hilly areas, in plain areas, how much time it will take to reach to that particular, so that some suitable warning could be given. So automated warning systems are being developed using this kind of a technology. So this is a simulation model of the uh, flood area in Kosi River with the help of the satellite image. So different year satellite images, different month satellite images have been superimposed, and it shows that how the flood is spreading into the area, damaging the area, and then how slowly it is receding back to the area. So this is all I wanted to tell you about the use of this particular tool and technology in different fields. That I would be happy to answer your query, answer the questions if you have any.
Hello.
Hello.
Yeah, I have finished, and I invite questions now.
Hello.
Yeah,
Hello, I am audible.
yeah, you are.
Yes, sir. I am Satish Gandhi from University College, Nagarkil from Tamil Nadu.
Mhm.
Sir, can you specify the booming area of the research work in geospatial technology?
Okay. Yeah. Yes. In fact, the question which you have asked is very, very difficult to answer, because the government of India is identifying in every project the use of this particular technology. So at present, for example, the interlinking of the rivers, the smart city projects, the digital India projects, everywhere this is being used. But there are many areas uh, for example, the urban growth, or 3D city mapping, or high speed rail corridor, where this particular technology is providing a great input. So you name the area and specialization, then accordingly their focus can be made to those research problems, because this is a multidisciplinary area. So depending upon the discipline, people are finding the applications.
Okay, sir. Thank you. Thank you, sir.
Professor, I would like to come in, and
Yeah,
this
yeah,
is
sure.
Dr. Sarup, Director
Yes,
General of
sir.
CIDC.
Good. Yeah, good
Now,
afternoon,
my
sir.
friend had good afternoon, and let me
Good
tell
afternoon.
you, it was a
Yes, sir.
pleasure listening to you today, and I'm very sure that in spite of the hiccups that we had for this program right in the beginning,
Yeah.
it was
Yes.
all worth it. As a matter of
Right.
fact, for the benefit of all the participants who are here, let me tell
Yes.
you that while I was listening to you, I was remembering a very interesting Hindi movie that came some
Mhm.
20 years ago with
Mhm.
Arshad Varsi in the lead.
Mhm.
And this was a very interesting movie in the sense that it was based on the real life experiences.
Mhm.
And this hero is supposed to be a police officer, a young
Mhm.
police officer in the state of Uttar Pradesh.
Mhm.
Uttar Pradesh at that point in time had many criminal situations, and there were, the criminals who were moving around everywhere, and they used to have the mobile telephony with them, and that is
Mhm.
why it was very difficult for the police to catch hold of them.
Yeah.
So there was one SIT that was constituted, and this young man was brought in there.
Mhm.
And then he called in some professors to start teaching his people as to how they can do the job. And after the third class, third round of classes, uh, he just went to check with his people and said that have you been able to understand anything?
Mhm.
And they said, sir, it is all overhead transmission, which meant that it wasn't really coming to our head.
Right.
So then he goes and looks for a professor like you, Professor Garg. And here comes this professor who actually handholds all these policemen, teaches them the mobile telephony, and then rest is history, where they were able to wipe out the entire criminal tribe there in Uttar Pradesh. So, what you spoke has a lot of value, has a lot of meaning, and all of us, and even people like me who were not really fully aware of the kind of expanse and the multi-dimensional kind of application, I was able to understand everything. I am absolutely certain my friends also here have benefited quite a lot. So
Yeah,
there are plenty of questions, and I
yeah,
will just
yeah,
touch upon the question that my, uh, the predecessor asked,
yeah,
and that was to let you know the kind of live research areas.
yeah.
Let me tell you, Mr. Gandhi, Professor Gandhi, that
Yes, sir.
the project topics, research and development, is something that has to be understood to be need based, which means that if we look around in our environment and have a look at the kind of situations that we are facing, we should be in a position to really find out the solution, and the researches would be done accordingly. And that is something that you have to apply your mind. You have to keep observing. There is nothing like a ready made solution that you have. If you were there in my earlier addresses to you, you would remember that story about sawtooth tiger curricula. So there is nothing standardized which either me or Professor Garg can really respond to you. You have to look at the kind of need, and you have to look at the kind of scientific and technical tools that are available to you. I was so happy when he said that it is not only construction, it is also many other activities that we do where basically we can use this whole technology to our benefit. And I think that is the essence of the whole thing. So
Yes.
let me give you an assignment today, Professor Gandhi, and to rest of you also. Start thinking of the areas where such technologies can be applied.
Yeah.
We know about GIS techniques, we know about LiDAR techniques, we know about how to use the unmanned aerial vehicles, and then rest of it is actually the multiple of whatever we are doing and the advanced equipment that we have with us, and how best can we use this whole thing for many applications. May they be transportation, may they be industrial production, may they be management and projection, whatever you may say. Everywhere this kind of technology and these techniques can be used. And I will once again compliment Professor Garg. This is one of the finest lecture I have really listened to. My compliments to you, Professor. It was
Thank you, sir.
lovely and
It was,
beautiful, and everybody could really be struck with what you said. And I'm very sure there are going to be plenty of questions. And
yeah, I
the
will.
basic purpose of this particular series of exchanges is
Yeah.
to make sure that the way we think gets transformed. First of all, we have to understand that engineering solutions are going to be of paramount importance. All the branches merge there. We cannot
Yes.
live in silos, and we have to start looking at a kind of a composite solution. That is the first thing. The second thing is that whatever we are learning, and this particular learning is the most valuable learning, this we have to transfer to our students also.
Yes.
Because ultimately, it is our students who are going to be building the future of not only this country. I have said that all over the globe, our people will be there who will be doing the things. After all, we are one sixth or one seventh of the entire humankind. This is what basically we have to bear in mind. So please convey this thought to them. And how can this come? This can only come when you have the multiple choice questions that you have to prepare and send across. When you ask a question, and especially an intelligent question, believe you me, lot of education is actually stitched right there itself. And it puts somebody on a pavement where he starts moving out in the direction to gain knowledge and wisdom, and that is what my old teachers taught me. So please follow that. Next, I have to tell you, and we have to involve our students in there. As a matter of fact, I would like our educational institutions to become powerhouses. They should be the one who should come out with the kind of brilliant ideas, because industry neither has the time nor has the level of understanding which all of you have. And that is a kind of a sacrosanct responsibility of the teachers in any society to make sure that the community and the society is guided thoroughly. And that is where basically I would suggest that use your institution, use your students. And in that context, let me share this happy news with you that CIDC has launched a national register of interns. And I would very strongly urge upon all of you to make sure to talk to your students and make sure that they are part of the National Register of Interns. When they go around, their teachers go around, meet up and interact with the industry, it will give you lot many ideas. And I'm absolutely certain many of you will encourage your students. You can get in touch with the secretariat and they will help you to make sure that we can do the things. We have very recently, just 2 days ago, on Saturday itself, inaugurated this whole thing. And I would like all the institutions who are represented here to get in their students who should be part of the National Register of Interns. That is going to be our greatest resource, believe you me.
Very
Your students will make you proud, your work will make you proud, and that is precisely what we are looking at that. There are two more small informations I wanted to give you, and that is that Engineering Council of India is basically organizing a very interesting conference on sustainable development on 25th and 26th February. My open arm invitation is to all of you. And especially you can reach out to your colleagues, your network people, let them all come and join. We will be talking about sustainable development, and the speakers, as usual, are going to be some of the finest people in the industry that we have here. Details will be sent to you. Kindly have a look at it. And the last thing, but not the least, I would like all of you to start considering joining many of the professional groups. That is an absolute essential for all of you. We'll send you the details of engagement with Engineering Council of India, with the International Council of Consultants, with the Indian Society for Trenchless Technology, which specializes in the subsurface infrastructure development and things like that. So I think with that, I'll just hand it over to Mr. Mishra and please come out with few more questions. And Professor Garg,
yeah.
may I make one more humble request?
Please do.
Your lecture has been absolutely beneficial and wonderful. It was a real sparkling example. This
Thank
whole
you, sir.
proceeding is being recorded. This whole proceeding is being recorded and it is going to be on the web. And those who could not, because of the problems of the connectivity, not join and be present for the initial passages which Professor Garg gave, the recordings are going to be there. My request to all of you is please listen to the whole lecture once again. Please do that. That is something which is going to be a great eye opener for all of us. Great eye opener, and I recommend it very strongly. Please go through that. It is going to enrich your knowledge. It is going to open the kind of doors and windows uh, and let the new ideas flow in. So that is precisely what we'll be looking at. With that, all I will say is to pray the God that He must bless us. And thank you so much for joining. Mr. Mishra, we can entertain few more questions. Professor Garg is here. And I would like this whole thing to be repeated once again. And we'll find out another session where we will once again request Professor Garg to come and re-deliver his lecture in person. And that is my request to you, Professor. We will be very, very obliged, and this is a request that I am making to you, and I am sure you would not say no to me. That is
Thank you.
something that I am taking for granted. Thank
Yeah.
you so much, sir. Thank you.
Thank you, sir.
Thank you.
Thank you so much. Dr. Sudha Balagopan has a question, I think.
Yes,
Yeah, thank you.
please.
Yeah.
Thank you, sir. In
Yeah.
fact, I repeat the words of Dr. Sarup that it was such an interesting session, and that I felt that my students as also my colleagues should listen to it. And so now I'm glad that it will be on YouTube such that I can pass on the link to them such that they can also listen to it. In fact, we would like to be a part of everything that's going on here. And today made me feel that perhaps it was a very good decision to join this particular faculty development program. But still, I have a small kind of not a doubt, but a sort of an application problem where I see that one of the important difficulties that infrastructures face happen to be vibrations, isn't it? Vibrations, be it a building, be it a bridge, or be it a railway track, or anything, even power lines. We have different kinds of vibrations, giving rise to sag, as also even cutting of lines, etc. So, does the imaging help, or can we extend the ideas that you spoke about to such an extent that we can think in terms of extending this? This is one problem. Another problem that I see is the interstate difficulties that right now even my state has with Tamil Nadu with respect to the water in the reservoir, the height, etc. You were talking about that. But then regarding the pressure, it is essentially the pressure that's creating the problem, the cracks, etc. So can we solve interstate disputes using this very powerful technology? According to you, okay, because you're such a knowledgeable person, it will be nice to know about it. Of course, I can't do anything for my state, but at the same time, it's nice to listen and then pass on. Okay, when we talk to our students, all these ideas can be passed on to them. That's all that I can do, and that may be good for them, for their own development, for their own thought process. Thank you. Can I?
Yeah. Yeah, yeah, certainly, yes. Yes, wherever there are vibrations, there are deformations, and uh, there are minor changes which are taking place. We can certainly identify using geospatial tools, and people are using GPS technology. They are installing the GPS devices there and monitoring the coordinates of those points. This is number one. But if we have a fear of losing our instruments, then in that case, the people are fixing the targets at those places with known coordinates. If I monitor those targets from my instruments continuously, continuously means after every 15 days or after every month or after every week, then if there is a vibration during that time, or there's a shift taking place, with the help of those coordinate system, images are taken, and with the help of those coordinate system we can determine the uh, deformation or the vibrations. If we have to find out the vibration and we do not know when the vibration will actually occur, then the GPS technology is the best in that direction, because the earthquake monitoring of the entire Himalayan region is being done with the help of the GPS technology. So that is the best. But if we have to continuously monitor a particular area, then we fix the target and we know the coordinates of those targets, and we continuously monitor, take the images and determine the coordinates of those targets. And if there is a change in the coordinate system, then we find out which direction the change is taking place. Your second point was about the water, how to resolve that particular issue of the water dispute problems. In fact, as a technical person, as a technocrat, what we can do is we can only carry out the modeling part of the, we can find out the quantity and quality of the water which is available in different watersheds, across different states. But these are more of a political problem, really, to transfer the water to another state when there's a lean period and surplus water available in the other state. This is all purely political issue, but technically, yes, it can be done. That modeling can be done. The water balance study can be done. If there is a surplus water in a particular river, how to divert that water to another state or to a canal system, so that the flood kind of a situation doesn't occur in that particular area. So these tools can help us in carry out the qualitative and quantitative study, the availability of the water during pre-monsoon, during the post-monsoon period, uh, using multiple, multi-temporal images, multi-temporal data that can be done. So,
Sudha, I have
Yes.
uh,
something
Yeah.
to add what
Yeah.
Professor was talking about. And professor is, of course, the most knowledgeable person, anybody who's sitting here. Uh, I am a bit of a mischievous person, and I am an executive, and I am an administrator also. And let me tell you something. Everybody in this world is scared mortally of the kind of prediction which the doctor makes that you are going to be dying in next about 8 months' time. If you do not quit smoking, if you do not quit eating all the sweets and things like that. And where from the doctor makes these kind of decisions? He looks at the kind of pathological report, he looks at the kind of investigative reports, and then he says that, my dear friend, you have limited time in this world. And believe you me, even the strongest of us gets a scare in his life. And if that wife of mine is standing by my side, believe you me, then everything is rationed and things like that. Now, moral of this story is that if we really want to do few things, never ever think that all you can do is to go to your students and tell them to study something and things like that. Be a little more scary. And this is a message that I am giving to all the teachers. Be very scary and tell these politicians that, look here, if you do not do like this, if you do not do A, B, C, D, E, F, G, H, you are going to have blood of thousands of people on your hand. Believe you me, they will be forced to listen to you, they will be forced to come back to you, and there will be some improvement. I do not promise that everything will change overnight, but fact of the matter is that we have to continue scaring these fellows who are ignoramuses, who do not know anything, who play politics. And in South, of course, the water politics is as strong as it is in North. And everywhere, anybody thinks that water is their own property. You can't hold the water like that. This is something which is the first principle in the life. So, Sudha, don't underrate yourself. You are a participant of FTP program, and the intent is that I am here to change your mindset totally. So be brave, go out, be candid, be honest, because what we speak, we are the slaves of scientific principles and mathematics. It's as simple as that. And there is no science in the world which can be corrupted. The only science is mathematics and the basic laws of physics and chemistry and mechanics and things. We are the slaves. We will only listen to that and nothing else. I hope I can clarify this to you. Right, Sudha?
Yeah, you did. Yeah, you did. Moreover, you
Yeah.
added the
So
fact that
go.
the instrumentation is supportive. Otherwise, if we talk about eigenvalue analysis, etc., the politicians will never understand. But the
Yeah.
instrumentation will pull them, will actually convince them a little
No,
more. In fact,
no, no,
I had
no, 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 don't go and talk to them and give them any technical jargons. Give the final outcome to them. Say that you are going to be in great peril. And believe you me, a politician is mortally scared in case he gets a sense and a wind that there is going to be some serious problem waiting for him. So scare them. Let there be a kind of a scientific group created within your own institutions. Make certain predictions. And those predictions, I believe, they are going to be based on the scientific facts, truth, and things like that. So let us basically start playing that game. After all, we are the most intelligent people. We basically become engineers after so much of toil that we do. We are honest in our approach. We are proud to be engineers. We can teach a few things to these people. Go out and do it. That is what I want you to do.
okay.
Okay?
Thank you. Okay, thank you. Yeah, very much so.
Right. So, any more questions? Any more questions? Although I have requested Professor Garg to be with us once again, and his recordings are all going to be there, but fact of the matter is that it is a great opportunity for us to have a person like him with us and take full advantage of it. And secondly, all the recordings are available on CIDC YouTube channel. You can go to your students and tell them to subscribe to it. It doesn't cost any money. And you too subscribe because there are many deliberations that are there. and it has plethora of information, wisdom, and the people who will be talking to you there in the YouTube videos are going to be the best industry captains, best scientists, and best technocrats. So advise that to your students also. Okay, Mr. Mishra, please take over.
Sir, thanks, sir. I again request to honorable academicians to come forward and interact with Professor Garg. In fact, uh, it is a rare opportunity for all of you that Professor Garg is here and is sparing his very, very valuable time with us to discuss, to give the opportunity to discuss the topic like the related to the geomatics engineering or GIS yeah, remote sensing technology. So I again request all of you to come forward. If there is no any question, uh, uh, we may close the session, and on behalf of Construction Industry Development Council and Engineering Council of India, uh, I would like to extend my sincere thanks to Professor Garg, Professor P.K. Garg. एंड सर मैं आपको ये जरूर कहना चाहूँगा कि आपके साथ रहना ही एक लर्निंग है और ईश्वर ने हमें समय दिया कि मैं आपके साथ आपके स्टूडेंट के रूप में भी रहा और आपके छोटे भाई के भी रूप में रहा.
Mishra ji, I am also learning from you. A lot of things I have learned from you also.
सर 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 ऐसा 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 मैं नहीं कर सकता हूँ सर, लेकिन 6-7 साल पहले जब मैं GIS सुनना शुरू किया था तो ये मेरा सौभाग्य था कि आपका साथ और आपका मतलब आप मेंटर के रूप में मुझे मिले सर. तो पर्सनली सर हमेशा मैं आपके लिए कृतज्ञ रहता हूँ सर. इससे अधिक मैं पर्सनली मैं कुछ कह नहीं सकता हूँ. अदर एंड इन जनरल always we are very happy and privileged to have session with you, sir. And our Director General, sir, has expressed our thoughts, sir, our feelings. Thanks, sir. Lot of thanks.
Yeah, so I also thank Dr. Swaroop and Mishra ji for giving me this opportunity to interact with the faculty of this very important program, because as I earlier mentioned that multidisciplinary approach is what is important nowadays for sustainable development, and this is the one of the important agenda of new education policy 2020. So organizing such kind of a program where people are sitting from the different specialization, attending it and appreciating such programs, this is a great achievement for CIDC, and I really compliment all the efforts made by CIDC in this. Thank you.
Sir, thank you. Thank you. So, sir, we are going to close the session.
Yeah.
Thanks a lot.
Thank you.